Hello everyone. In this video we're going over activity 5.2 in using jamovi. Right? So for this particular example, students were asked to read a challenging section of a textbook, and they were asked to estimate how much time they spent reading that textbook. So everybody was stopped after 23 minutes. And so what we want to know is how close was their estimate of how long they spent studying that textbook to the actual amount of time they spent studying. And for everybody, the actual time spent studying was 23 minutes. Right? So to do this analysis, we're going to do a single sample t-test. So I click on t-test and choose the one sample t-test. And then our one variable in this data file is the time estimate. So we're going to use a different test value here. Note that jamovi defaults to a test value of 0. But we don't want to compare our sample mean to 0. What we want to compare it to is 23. So you have to change the test value here to 23. Okay? We're going to stick with the same default hypothesis. We're doing a two-tailed test, and jamovi defaults to doing a two-tailed test here. In addition, we're going to need a mean difference with a confidence interval around that mean difference, the effect size with a confidence interval around that effect size, and descriptive statistics and plots here. Okay. So you can see that we have 67 people in our data file, okay, with a mean of 30.25. So people actually read for 23 minutes, but they thought they read for 30.25 minutes. And so we computed a single sample t up here to compare that mean of 30.25 to 23. Right? And so you can see that the 23 is listed here as a reminder that we're comparing our sample mean to 23. Right? So we get a t here of 9.41 with 66 degrees of freedom and a p-value that's less than 0.00001, a very small p-value. So what that p-value tells us is that there's a very small probability that I would get a t of 6.41 if in fact the null hypothesis were true and students were accurately estimating how much time they spent reading that particular material. Okay, so the difference between the time they estimated and 23 on average was 7.25. Our 95% confidence interval shows us that we can be 95% sure that the true value of that mean difference is somewhere between 5.71 and 8.79. Now, if we look at the effect size, Cohen's d, you can see that our effect size is 1.15 with a 95% confidence interval with lower bounds of 0.83 and 1.46. Right. This is a large effect. The effect size is 1.15, and we're 95% sure that the true effect size is somewhere between 0.83, which is really large, and 1.46, which is also really large. In terms of additional things that you have in the output here, we have the mean, median below, the standard deviation, right? And the standard deviation tells us the typical distance that scores are from the mean. The standard error of the mean is the typical distance that sample means of a size of 67 are from a population mean, or the typical distance we would expect between them. This is an estimate because we're using estimated sample data. Okay. All right, and that is all you need for analyzing and working with the data here in activity 5.2.